Okay, so let's start. Welcome to our presentation about Zephyr in education. This is my colleague Flavio. My name is Vixay. We both work at the Institute of Embedded Systems, which is part of the Zurich University of Applied Sciences in Winterthur, Switzerland. Our research focus is the Internet of Things. So, what are we doing with Zephyr? So at our institute, we started using Zephyr back in 2019. So Zephyr was evaluated in a master thesis, so when it was in version 1.14. After the master thesis, which showed that Zephyr is very good, we started using it in several research and development projects. We also started to use Zephyr in several lectures of the bachelor and master's program. So we have, for example, the Microcomputing Systems 1 in the bachelor's program, embedded real-time software in the master's program, and so on. Also, some students use Zephyr to implement the firmware in their bachelor or master thesis. For example, we have the embedded real-time software course in the master's program. The students learn how to avoid things like race conditions, deadlocks, etc. So they learn how to use mutexes and semaphores. So it's just basically embedded programming close to the hardware, facing real-time problems. In this course, the students have, besides the lectures, also laboratories where they practically try to solve problems. For example, the dining philosopher's problem. Maybe you have seen the demo at the Zephyr booth. So in this picture, you can see the green base board, which is a custom board with buttons, LEDs, and switches to play with. On top, we have the blue discovery kit from STM. On the display, we have visualized the dining philosopher's problem. So in the labs, the students use these boards and implement their solution on these boards. Yeah, so I will skip this. So when we do the labs, we face the following problems. Usually we only have 2 hours per lab. And Zephyr RTOS is new for the students. The students want to learn something in this time. They usually don't want to stay longer. And when it comes to setting up Zephyr, we have another problem. This is how the classroom can look like. So every student has a different setup. Some have Windows laptops, MacBooks with Intel or Apple Silicon, Linux, etc. So installing Zephyr differs on each setup slightly. So we as a lab supervisor must be able to provide help efficiently, which is quite challenging with all these different setups. Therefore, we need a solution.
Exactly. So we need a development environment that works for everyone. And first we have to write down some goals. Well, we want, of course, that it works for every system, but maintaining this, we don't want to maintain like a new environment for each system. So that's why we want a single uniform environment. We want it to be reproducible, easy to maintain, and for the students, easy and quick to set up and easy to use. Well, first, our initial solution used to be a Ubuntu desktop virtual machine. As you can see, we identified lots of problems. Well, for us, it wasn't reproducible, very time-consuming to set up and maintain, and most importantly for the students, it was such a large file to download, and they always complained, especially if they only want to use it for one lab. Also, it was running very slow. We forced them to work inside the VM. They couldn't use their favorite text editor like VS Code, and the file sharing was unreliable. Also, we sometimes had the problem that the system prompts the user to install updates, which gives lots of problems as well. So this will bring us to our current solution using containers and Windows subsystem for Linux images. Well, we can see we have advantages like finally it's sufficiently reproducible. The students only have to download a very small file. It's very fast. We have reliable file sharing. And finally, students can use their beloved VS Code. But we don't have a perfect solution. There's a big disadvantage. On WSL, hardware is not accessible out of the box. For example, if we want to flash our board, we plug it in via USB, want to do West Flash, but this doesn't work. There's lots of different solutions to this problem. Every solution has their own problems as well, but we think our solution works the easiest for every type of system. So we use Zephyr tools, for example, JFlash Lite on the host to flash those boards. Here's a typical view of a student using Windows and JFlash Lite. As you can see on the left side with the red arrows is a WSL Linux. Under there, they can go to their project and search for their binaries to then flash their board. So let me quickly show you how the container is built with a simplified version. As a baseline, we have Debian, and then we just have to install some packages, Zephyr SDK, and then we clone Zephyr. It's simple as that. It doesn't need much more. Building it is simple as well. As an example, we now use Podman. You select your version, which you need for your labs, modules you need for your labs, and also some additional packages as well. And here you can see it's perfectly reproducible. It's easy to maintain and use for us. But maybe you're thinking, okay, well, using a container on Linux and Mac, pretty easy to use. You just use or run a container environment. But on WSL, do you use something like that as well? The answer is no. There's a very simple and elegant solution because you can simply export the file system of a container, and this file system can then simply import it as a WSL distro on Windows. And a little fun fact here, building a Zephyr application like this on Windows is actually the fastest way, even faster than building Zephyr application with a Zephyr installation natively on Windows. Well, we successfully conducted several iterations with these containers and with the students. We can say it's a pleasant setup experience and it worked with every kind of system, and all students had a working setup in the end. And most importantly, the students gave us a positive feedback in the end. And with that, I want to thank you very much for listening to our lightning talk. On the right side, you can have a GitHub repo of our development environment. It's the left side, actually. And on the right side, some more information about us. Thanks. Yeah.
Do you do in-tree development within the Zephyr repository then with the students, or do you have like a separate
I think we actually have separate, yeah. But it's very versatile. We can basically do it however we want, yeah. Yeah, more questions?
I just want to make sure I understood something properly. You said it was faster to build in WSL than in Windows native?
Exactly, yeah. For this, you can look at the repo and there's like more information and reference down below for the benchmarks, which we found. We didn't do it though.
As far as I heard, the reason is because Windows otherwise checks every build file with for antivirus and so on.
I heard this as well, yeah. Even disabling, so it's still faster. So that's the way to go, right? Don't use Windows, I guess. Woo. Yes?
Do you also standardize on the debug? For example, do you ask? I know you mentioned that everybody can use their own environment, development environment, but when it comes to when you teach the students how to flash and debug, do you specifically tell them to use West Flash and West Debug or a plugin in VS Code, or is that up to the individual students?
How do we actually do this? So the question was, how do we teach them how to flash and debug using Zephyr?
As far as I know, we just say in the labs they have to use the Sega JFlash Lite to flash the tools, flash the firmware.
Yeah, but that's the access to the file. But then, they actually go and load JFlash into the GUI and.
Yeah.
Yes. Later, when they do their bachelor or master thesis, we tell them to do it differently, even install Linux, basically. We force everyone who works at our place to do that, actually.